All right, guys, we're going to get started with day 2 of our 8.6 notes. We're talking about distributing with polynomials. Remember to write your notes down because you're going to be turning them in, but not the purple sides. Okay, so what is distribution? We have talked about distribution before a lot of times. So there are two different ways that we could simplify this expression here. If you're following your order of operations, the first thing you need to do is your parentheses, then your exponents, then your multiplication, division, addition, subtraction. So we'll start with the parentheses, and I see that we have 10 plus 5. Well, can we do 10 plus 5? Yeah, 10 plus 5 is 15. So this is really 2 times 15. And now we can do our multiplication. I know that 2 times 15 is 30. So this equals 30. But the other way that we could do this, we don't actually need to start inside the parentheses because there's this fancy thing we can do with this 2 out front. We can distribute this 2 to the 10 and to the 5. So we get, all right, so we end up with 2 times 10. We bring our plus sign down right here. And then 2 times 5. So 2 times each of the things that were inside there. And now we can go ahead and simplify. Let's do our multiplication first. 2 times 10 is 20. Bring down the plus sign. 2 times 5 is 10. Okay, 20 plus 10 is 30. So either way, we still get 30. I'm going to go out on a limb and say that this first way was much faster and much easier. But there is a reason why we have that second way, why we ever even bothered to distribute that too. Here's why. Because what if we had this type of an expression? So now, if we wanted to start with inside our parentheses, if we wanted to start with this x plus 5, do we know what x plus 5 is? No, because we don't know what x is. X is a mystery number. So we can't do it that first way. There is no first option. So instead, the only thing that we possibly can do is distribute the 2 to the x and to the 5. So it'll look like this. All right, so we distributed our 2 to both of our terms. 2 goes to the x, 2 times x, bring down the plus sign, and then 2 goes to the 5, 2 times 5. And now we can simplify this. Instead of writing 2.x, it's better to just write 2x. And then we know that 2 times 5 is 10. Now, can I add 2x plus 10? No, because they are not like terms. So that's as far as I can go this time. All right, let's do example 4. Go ahead and pause the video and try these both on your own. When you unpause it, I'm going to put the answers up here and you can check to see if you got it right. All right, so let's talk about both of these. These are the right answers that are circled up here. So this time we distributed an 8. So we have 8 times the x. We have 8 times the 11. We brought our minus sign down. 8 times x is 8x. 8 times 11 is 88. We can't do 8x minus 88, so we stop there. This one we distributed the 5, so you can see that the original terms, the 2n and the 4n, are right here, but now both of these have a times 5 out front, and that plus sign just got brought down. Okay, and then don't forget 5 times 2n, you just do the numbers first. Well, 5 times 2 is 10, we still have just an n. 5 times 4 is 20, we still have just an n. And then can we add 10n plus 20n? Yes, because those are like terms. So this time we actually can go one more step and we get 30n. All right, so what if we have an expression that looks like this? This time it doesn't tell us to distribute a 4 or a 5. We have to distribute this ugly thing, this 4x squared. So we're going to go ahead and we're going to distribute that 4x squared, and it's really not going to be too much different. I'll distribute in red again. So I'm going to do this 4x squared times this x and times this 2. So I have 4x squared times that x times x. Bring down my plus sign. And then I have 4x squared times the 2. Okay, so my original terms are right there, x and 2, but now you see that we have this 4x squared out front. Now I'm going to go ahead and simplify because I know that 4 times x squared times x, well, how many x's am I multiplying? This is x times x times x. That's x cubed. So this is 4x cubed. Still have that plus sign. And then this one, 4 times x squared times 2. Well, remember, do your numbers first. Do the coefficients. So 4 times 2 is 8. And then x squared doesn't get multiplied with anything, so it just stays x squared. Okay, are these like terms? No, because they have different exponents, so I cannot add them together. So I have to stop there. So same idea as before, But now the thing that I'm distributing is just a little bit bigger. It's not just a plain number. There's also a variable and an exponent I have to worry about. All right, so example 5. We're going to do A together, and then I'm going to give you a chance to do B on your own. So go ahead and pause the video and write it down. And now what we're going to do is for A, we're going to take this n and we're going to distribute it to the n cubed and to the 2. We're going to bring this minus sign down in between. So I have n times n cubed. Bring down that minus sign. And now I have n times the 2. Okay, pause there if you are mindlessly copying stuff down and look at what you just wrote and make sure that you can make sense of where these numbers came from. Okay, so this n cubed minus 2 is what we originally had. They just both have a times n out front. Now we're going to go back and simplify. What is n times n cubed? Well, that's 4 n's multiplied all together, so it's n to the power 4. Keep that minus sign, and n times 2, well, it's much better to write 2n. All right, are these like terms? No, because they don't have the same exponents, so we cannot subtract them. All right, pause and try B on your own. I'll have the answer up here so you can check it. All right, so I just want to show you what it looks like after I distributed my 2k. So here's the original, k to the power 5 plus 3k. But now I've got that 2k squared out front of both my terms. So now I'm going to keep going. Okay, so now I have finished simplifying. On this one, k squared times k to the 5th ended up being k to the power of 7. On this one, I did my coefficients first. 2 times 3 gave me 6. And then I looked at my k's. I had k squared times k, so that's k cubed. I cannot add these because they're not like terms. They don't have the same exponents. So that one is done right there. Okay, so as your polynomial inside your parentheses gets longer, it starts to make the problems look very intimidating. But this is actually not any harder than what we've been doing. We still just want to distribute this 8. But we're going to distribute it not to 1 term, not to 2 terms, but to 3 terms, because there are 3 terms inside this polynomial. All right, so no different than before. Do we have any like terms here? Nope. I have k squared and I have k, different exponents, not like terms. So this is my final answer. All right, go ahead and pause the video and try A on your own. Unpause it when you're done. You can check your answer. All right, so here's what we end up with for our final answer. 14x squared plus 7x minus 28. So you do not necessarily need to show this middle step. I'm showing it so that it's very clear where that 7 is going. But if you can just do this in your head, 7 times 2x squared, and you know, oh, 7 times 2 is 14. The x squared stays x squared. That's fine. I'm sure you can do 7 times 4 in your head and just jump straight to 28. You don't need to show this 7 times 4 necessarily. All right, let's look at B. So this time I'm distributing an x. So I'm going to distribute that x to each term here. So really what's going to happen is I'm going to have one more x than I already have in each term. So instead of 3 times x to the power of 5, I'm going to end up with 3 times x to the power of 6. And I'll show you why. I'll actually write out that middle step. All right, so there's our middle step. You can see that we had 4 terms, 1, 2, 3, 4. Each of them got their very own x, which you can see in red here. So now I'm going to go ahead and simplify. Well, x times 3x to the power of 5. Keep your number out front. There are no other numbers. And then x times x to the power of 5 is really x to the power of 6. Okay, this one plus x to the power of 5 minus, bring your coefficient out front, that's your 2. X times x is x squared. Okay, minus, and x times 1 is just x, so minus x. Now check for like terms. I don't have any this time because all of my exponents are different, so I have to stop right here. So on this one, I expect a lot of you would just see, oh, well, all of the exponents are going to go up by 1. And so, yeah, you can definitely just jump to that step instead of having to write all of this out in the middle. But I want you to see where this is coming from. All right, this is our last slide. You do not need to write this down, but you can if you would like. This is somebody made a mistake in this work. So take a second, pause the video, and look at it and see if you can figure out what their mistake was. All right, so they knew that they were supposed to distribute. You can see their arrows on top. That looks beautiful. They knew that they were supposed to distribute to both terms, but did they actually do that? No. Yes, they multiplied this first one times this x. I see that right here, times x. But they did not do their 9 times x. So that's what their problem was. So they just forgot to distribute the x to the second term. So there should really be an x on the second term as well. We are going to forget that like 50% of the time. Even if you can see it right now, that's a very common mistake. So make sure that you are on the lookout for that. Don't forget, even if you're drawing your arrow, actually multiply your x times your last term. All right, go ahead and submit a picture of these notes and then check out the assignment that you have on Classroom.